tutorial. So you have to install Paperproof VS Code extension, and you have to require Paperproof Lean library. And after these two steps, you will be able to do this. So you can import Paperproof and click on this icon. And then click within some theorem and you will see this rendered. So Paperproof has two types of hypotheses. First one is yellow and second one is green. Yellow ones is data and green ones is proofs. So these are just normal hypotheses. You can treat them all the same, but usually the yellow ones is what you want to run induction on, and green ones is proofs on you, so you can use it to prove something. So here we want to prove x equals to y, and you see this goal here. So this is the initial goal. And as we prove it, we go towards the middle of the proof. So we go from top down and we go from bottom up. Okay, so what happens when you type stuff? Let's delete it first. So we start from this state, and then we add tactics, so that would be x, then apply if intro. So see, we used to have one goal and now we have two goals. And currently we want to prove this goal, and the hypothesis that we have is x, s, and t. So we did intro, and therefore now we have a new hypothesis and we want to prove this. So now we're in the mode that has compact tactics, but you can disable it. If you have really nice small proofs, it's usually prettier to have wide tactics. It's also possible to do read-only mode. It's especially useful if you're not currently writing the proof, but you're reading some file and you're trying to understand the proofs. So all the hypotheses and goals will always be highlighted in this mode. You can also have compact mode, which will remove all paddings. When you have a box, you can collapse it. First of all, so suppose this is a really large proof and you scroll, and if one of the hypotheses are out of your view, out of the viewport, you will see it fixed, so you never lose your hypothesis. Okay, so now we do exact. And we have proved this goal, so only this goal is left to prove. And we can collapse a particular box by clicking on it, and then we can expand it again. So it goes like this. So we do the same now with another goal. So intro, then rewrites, and then assumption. All right. So when you see simp and many other tactics, it will show you this green arrow, and this green arrow means that this tactic used up a particular hypothesis. So here we can see that this simp used h1 but did not use h2, which is logical. Like this is what we wanted here. When you have calc, it's obvious that this is a transitivity thing, and again gcongur shows which hypothesis was used up. Paperproof will nest hypotheses with the same names under each other. So here this rewrite h rewrote, for example, rewrite h. So it rewrote cd b equals to c to e equals to c. So, and because they have the same username, these variables, the username is cd, they are nested under each other. This is a typical proof from Mathlib. Let's do read-only mode. This is a typical proof from MATLAB, and you can see that here we have a rewrite, which is like if you use InfoView, you would have to click on each particular rewrite to see what it's doing. But with Paperproof, this rewrite gets expanded into many. You see each step how it gradually was building up. So cases and okay, it's like this. Cases and induction and rec on have uniform interface. So if you have an inductive which was created by a single constructor like this, then it will always look like this. If you have it with two constructors, then you would have this parallel goal forking. This is reminiscent like you have in electric circuits, parallel connections and series connections. So, and when you see an inductive like this, it will be very visually obvious what you would have to prove if you were running induction on it. And combinations, when you have a combination like this in your proof, you can see what route exactly was taken. So this combination means that we are running we are trying to run each of these tactics, and when one of these tactics succeeds, we stop this part and we just repeat it again. So first we start from apply end.intro. We tried it here, and it worked actually. So it worked. We have two goals. So we exited this loop and we go on to another loop. So we try to do apply intro again. So we're here now, and we try to run apply and intro, but it doesn't work. So we try to do apply or.enl and then do assumption, and it works this way. So we close this, then we do the repeat again. So you see that Paperproof shows this entire process, and you know exactly what happened. Okay, now let's look at MATLAB. So previously, if you have tried using Paperproof previously, you saw that a lot of proofs in MATLAB, it would be very hard to work with because they would be really wide. But now most proofs are very compact. However, when you do find a wide proof, let's make it less compact. Let's try to find a really wide proof now. What should be large? No, everything is small. Oh my. Okay, this is pretty large. When you have a large proof, you can click on a particular window and then it will zoom in. And then you can scroll around. And also while you're proving, you will always have this zooming working automatically. And then you can click on this large box and it will zoom out it altogether. Okay, that's it.